Okay, so my name is Ian Cookson. I'm the product manager for application continuity. Joining me today, or part of the presentation, will be Gerald Fensel, who's the product manager for application development. And Troy Anthony, another of our product managers for high availability. We're going to be talking about application continuity for developers and whomever else may be interested in application continuity, but we're focusing on the development and the deployment of applications with this configured for application continuity. While I'm going to give an intro and positioning of application continuity, give you an idea of what it all does, we'll try and focus a bit more on what you have to do to make it work, or take advantage of it, I should say. And then we're going to show you a demo of exactly that. We're going to show you it working and some of the ways you can the way you have to configure, in this case, a Java application to use it. Okay, so that is for developers and those deploying applications. Of course, you're going to be working with DBAs behind the scenes. So if there's DBAs or people with database administration interests in the audience, that's even better. Okay, application continuity for developers, yes, but also for application owners, those people who are deploying applications. What is it, and what is it doing for you? Okay, so let's position this correctly first. Everybody, I think most DBAs at least, will be aware of the maximum availability architecture. And so the whole point of this is, if we look up in the top right, you see application continuity highlighted a bit there for continuous availability. Continuous availability of your application or the workload processing is the key here. And it applies, and in virtually the same way, across all the different platforms that Oracle currently runs on, whether it's generic rack systems, engineered systems, Exadata and so forth, whether it's in the cloud or XCC or XCS or the autonomous database. It runs exactly the same way, in configuration virtually the same across the board. Okay. Now, I've mentioned rack, and that's true. I mean, we're dependent on the availability of the data. It has to be there, hence the MAA architecture and stress we place there. So your production site would be a rack system, providing local high availability of the data. And the replicated site, which was a standby, it's an active data guard, again, for availability and disaster recovery. And we cover all those bases. And just to be clear, application continuity kind of fits into the silver level of MAA architectures, but most typically we see it in the gold in conjunction with Active Data Guard. So what is it? And what are we trying to achieve here? We're focusing on the user experience, as I mentioned. Whether it's for planned maintenance or unplanned outages, we want to make sure those are hidden from the users. All the in-flight work that they've submitted will continue to be processed behind the scenes automatically. The users and the application do not need to do anything to make this work. Performance becomes predictable, SLAs get met, and so forth. Key here is users are not impacted. Okay. One important concept we want to introduce, and this is primarily aimed at application developers so they understand what we're talking about when we talk about the unit of work and how it's the demarcation of that unit of work with request boundaries, begin and end request. Now, this is a Java example, but the concept applies whether you're on Java, OCI, or ODP.NET. In this example, too, we're using an Oracle pool. And you're taking a connection from the pool to start your request. You submit a number of statements, SQL, PL SQL, whatever they might be, and then you commit and or close the connection, return the connection to the pool to end the request. And that's pretty explicit. Your application is deciding by its logic when the request starts and when it ends. It considers that to be a unit of work. And the database processes that database request in the sequence it was submitted. Pretty normal stuff. But that request and those begin and end request markers are used for a number of functions within the database and for recovery and so forth. Okay, and we talk about them here where we're looking at draining. We drain the entire database request. Draining is for workload or planned maintenance activities, patching, and so on and so forth. We also use it for recovery or of in-flight work and replay, which is application continuity itself. Okay, so it's going to be people are aware of this. Now, the big difference here, obviously, this is a connection pool being used in Java and so forth. But for transparent application continuity, which we introduced later as of 19C database, now we're able to actually work without a database or a user connection pool. The database itself infers when the request begins and ends, all based on state changes and so forth in the session. Obviously, I think most of us would agree that explicit request boundaries are better because the application is determining when those occur. But for those applications that do not use Oracle connection pools, transparent application continuity is the key because it will manage where the requests start and end and allow you to do replays and so forth accordingly. Okay. So application continuity itself, let's just talk about that first. We really haven't positioned what it does. And that's really because it replays in-flight work on recoverable errors. Okay. Obviously, if there's a logic error or data error, we're not going to bother replaying. Okay. It masks outages or interruptions to the work stream or connections. In 12.1, we introduced it for JDBC Thin and also, obviously, the other Java-based applications using Oracle pools. 12.2, we added support for OCI and ODP.NET. Okay, again, using an Oracle pool. Now, as I mentioned earlier, we also introduced with 19C transparent application continuity that can work with connection pools of any kind. Oracle connection pool is better, of course, or no pool at all. So your legacy applications, your OCI applications, Oracle's got a bunch of those, e-business suite and so forth. They can take advantage of the functionality of the replay capabilities of transparent application continuity because that's what it's aimed for. Okay, and in fact, we've turned it on by default in the autonomous database dedicated version. Okay, so planned maintenance. Planned maintenance is where we see the biggest impact for this, and this is the big draw, you might say. The database has been able to manage a lot of this functionality for a long time, since 10.2 timeframe. But we use application continuity to enhance that so that it reduces or removes any impact to the users. And there are lots of places where we can drain the work. The concept of you submit in-flight work, the database processes it while new work is going elsewhere in the cluster, rack cluster in this case, right? So you submitted the work to node 1, it's being processed. In the meantime, we signaled that any new work should go elsewhere in the database, and all new work goes to node 4 maybe. Doesn't matter. We don't care. The users don't care. The key here is you're always being able to process your work. That in-flight work that was submitted will drain or complete, and then the connection will be returned to you or the pool for reuse. Okay, so the results come back to you, and so on and so forth. And that's how work plan maintenance works. Okay. And the way we enhance that with application continuity is by making sure that anything that still fails and because we can only drain for a certain period of time, we complete on your behalf automatically behind the scenes, and you don't know. You don't care. Okay. So what are the prerequisites to make this work? Well, the first one, it's hard to believe, isn't it? A well-behaved application. In this case, it's pretty straightforward. Most of it's simple, at least. No XA. Okay, we can't support that. But I mentioned connections being taken or released from the pool and returned. If there's a discipline around that, making sure that happens, cleaning up the state as you return the connection to the pool whenever possible, and so on and so forth. So we cannot stress enough the impact there, because if you're taking connection from the pool and not returning it, you don't know what's going to happen behind the scenes, and we cannot replay it. We cannot replay it effectively. We want to make sure you're using an enabled client stack. Now, what does that mean? Well, realistically, what we want is you to use the most recent drivers and so forth, whether they're JDBC drivers, Java drivers, or you're using OCI libraries and so forth. Just want to make sure they're using the most recent, because they're always backwards compatible. Okay. We also want to make sure you use a recommended connection string. You store it once locally in the LDAP or tnsnames.file, but we have a recommended connect string that will enable a lot of these functions on their own. So this is just a configuration change. You just make sure you're using the right connection string, and you're the most recent drivers, and you're all most of the way there. We configure the database and grid infrastructure accordingly. You do this once. You set up database services, or the DBA does. You request them based on your workload and the type of work you're doing. Okay. And lastly, you just make sure things are working and that they are meeting your SLA targets. And now, that's pretty straightforward, because for OLTP applications, this is what the focus really is on. Okay. Long-running batch most often has a restart capability built into it, or it should do. So that's not a big help. We can't help it there. Short-term batch, but primarily OLTP is where we're playing here. And that's the most common scenario we're facing anyway. So as an explanation, let me just go through this and what's happening here. We've got two nodes in a cluster, and we've got a steady workload on each. At some point, the DBA says, okay, so I want to do some maintenance on node 1. But to get to that point, I want to drain the in-flight work. Okay, so he issues a command start to initiate the draining. What that actually does, the first step, is establish a way for the users to connect to node 2. Okay, so that at no point in time will we cut off the users from being able to make connections. They will also always, I should say, be able to make a connection. This case is to node 2. In the meantime, we shut down the possibility of new connections coming to drain node 1, and we drain the work from there. The work is actually processed to completion and returned to the pool or to the user for reuse. Now, at the end of the drain timeout, the drain timeout could be 10 seconds, 10 minutes, 2 hours. On a rack system, we really don't care. And in fact, you shouldn't either. You should make that as long as necessary to get the job done. And if you think about the way that curve looks, if you just extended that drain timeout a little bit longer, you've got it all. You've processed all the in-flight transactions, in-flight database requests, and so forth, queries too, and you'd finish them all off, and then that'd be the end of it. Don't worry about it. But if your drain timeout is finite, in other words, there are, at the end of the drain timeout, whatever that might be, there are some of these in-flight requests that are not complete. Then what are you going to get? You're going to get errors. That's probably the state you are in right now. You'll get errors returned to the user or the application, and they have to deal with it, resubmitting whatever they might want to have to do. Okay. But if you've got application continuity configured, then it steps in and automatically replays those terminated in-flight requests. No errors returned to the users, and the application just carries on. No performance hit on this case with you in a rack failover scenario. Users won't even notice. It's almost impossible to measure this. Okay. Again, all functionality is readily available to you. So how do you do this? Well, you deploy your 4 easy steps. Well, it is that's simple, and I've mentioned them already. Configure your application. No code changes, just configuration changes. I mentioned the connect string. Also want to use the latest client version, whether it's Java jar, JDBC jar files or whatever, or ODBC libraries, OCI libraries. Let me step back here. 4 easy steps to success. You can just configuration changes. Configure your application first. No code changes again. Cannot emphasize that enough. Use the recommended connect string. This is all well documented. This all enables all the conversation and all the functionality to work properly for you. Make sure you use the most recent client version. This might be the JDBC jar files or the OCI libraries. Whatever it might be, use the most recent ones. Make sure the DBA is configured the right database services specific to your workload. Okay, you provide them some input. You can specify the drain timeout. Okay, because your OLTP application is going to drain within minutes, while your short-term batch may take an hour. And likely you're going to have a different drain timeout for it. And it's also on the service that you configure application continuity. Okay, and make sure, of course, your connect string actually uses that service. Grants for mutables. This needs only to be done once by the DBAs. Typically, it's grants for sequences and the next files and sequences and so forth. It's pretty blanket. It's easy to find out what those are. It's done once and you move on. And then, of course, you want to make sure things are working. Because we consider, if you think of what has happened, how do I prove this out? There's a number of steps to this. One is, as of 18C, we introduced the capabilities or added the capabilities to track statistics for usage of application continuity and its replay capabilities into the AWR reports. DBAs will be very familiar with that. And if you find exceptions in there or numbers that do not line up, you want to find out what is not replaying and why. And you use an AC check utility in conjunction with the DBAs to find out exactly what those are. And you can identify the calls that are not going to replay and why, and then you can take actions about them. Pretty straightforward. It's just that simple. Make your small configuration changes, work with the DBAs to get everything else set up properly on the database, and then check the results, and away you go. Okay. Now, it seems simple enough, and it is. You think, well, why can't I do this myself? Now, if you're just deploying an application, obviously, well, it's done for you in the database, so you don't worry about it. But if you're an application developer, you might think, surely it can't be that complex. I could do this myself. Well, it's not that simple. Okay? Well, maybe it is. You have to judge that for yourself. Let's just think about some of the complexities you might face and consider what the database is doing for you automatically behind the scenes with application continuity. First of all, can I reconnect? You've lost your connection for whatever reason. Someone's taken a database instance down to patch. Okay? Okay, can I reconnect? Where do I do it? How do I do it automatically? Can it be done? How do I do that without the users having to type something in? Okay. Can I rebuild my session? In other words, can I make it exactly the same as it was? And is that important to you? Well, it might be in some cases, it might not be in others. So if date, time, and so forth are important to rebuild to make sure they run everything's exactly the same as it was, or is it okay to resubmit it in terms of, well, the dates and times moved on, the sequence number and so forth has moved on? Well, maybe I'll be okay with that. And did it actually fail during the commit, or did it fail in the processing of one of the SQL statements or whatever I had in the database request? Because the way you handle it is quite differently. If it failed on just a SQL statement, you'll know where that is, and you can figure out what to do next. But if it failed in the commit and you never got a reply back saying, well, what happened to this, or the record's committed and saved, then you may be at a loss of what to do about that one. And that's a real dilemma. There are ways to find this out, but we've built all that into the application continuity for you. Don't worry about it, okay? Next is, should I replay it? Okay, well, we kind of addressed part of that already. But remember, should I resubmit this? Because, again, it falls from that commit question as well. But it's also time's moved on. So is it realistic to resubmit? You think in terms of an airline reservation. You submitted your reservation request at one point, and you never heard back. So should I submit it again? Well, the seat may have gone. The flight might be full now, or whatever. The fares may have changed. So how do I know I should resubmit it, and under what conditions, and the logic associated with it gets to be fairly complicated. And again, depends true on what errors or exceptions that are reported from the database. And these are always changing. Well, not so much changing, but as new versions of the database come along, we may add new exceptions, new errors or whatever that you have to accommodate. And if you're keying off what error number it is, then it's a bit more complex logic than saying, if it's error such and such, then I do this. There's probably more to it than that, especially as you know, things depending on your application. Then lastly, can I actually physically replay this? Can I replay it in a way that it results in exactly the same outcome as I originally submitted it 2, 3, 5 minutes ago, whatever it might be? Do I have sufficient information, and is it feasible to actually do it? Okay, and then again, what happens? What do I do if that replay fails? Is it, do I just say, that's it? Return the error and say, good luck, user, you're on your own? The idea here is we want to make it hidden from the users. We do not want to require the users to do anything, hence application continuity. So Troy, Gerald, you've seen this. What do you think? Is this important for developers? I mean, obviously, if you're deploying an application, you just off the shelf or whatever, or you have a current application, this type of discussion, these questions don't really come up. You see the benefits of application continuity as protecting your users or their workflows or work during various events. But if you're an application developer, do you think you should be building some of this yourself for OLTP or not? Why not rely on the database to do it for you?
Yeah, I think it's a very interesting concept, right? As application developers, we have to and build our applications for anticipated failure, right? Whether that's a glitch in the network, whether that's a failure of the server hardware where the application is running on, or of course also we think about what's happening if there's a database failure. Mm-hmm. From Ian, from what you told us, it sounds like that the typical applications out there have simple reconnect mechanisms built in. Of course, things like where you try and execute a given work item in a try catch block, and if something goes wrong, you just retry the entire work item. But there are various complexities involved, as you have said before, like you have a flight registration system and the seat that you were about to book is now gone. Can you just really catch the error and just try this all again? That developers may not think about.
Yeah, exactly. I mean, and application continuity in those type of scenarios is going to throw its hands up and say, I can't help you because I do not have the logic to figure out what seat you want to sit in if that seat's already taken. So again, we're guaranteeing to process the transaction or whatever it might be in exactly the same form as it was originally submitted. We can't apply new logic to say, well, if we can't do that, let's do this. So some of those complex capabilities to build or rebuild an application or context, you have to code for yourself, or the user brain. In other words, the user itself will have to figure it out. And that's perfectly viable. But there are occasions when, why not just, when we just have to resubmit what we have. It may be a slightly more complex than your catch block and so forth because of, well, we have this error. This could mean this or it could mean that. And if it means A, then I just want to resubmit it as it stands. But if it means B, then there's a bit more complex to it. And I've lost my connection. So do I reconnect to the database, rebuild everything? How do I do that? App continuity absolves you of that problem. Okay.
The good thing is that application continuity is happening before it gets to the error code. So the failure is trapped, and you have all your error handling, right? And that's still important to do. This is not a panacea for removing all your catch blocks. So, but before we get to that error code, application continuity has reconnected you to the database. So the Ian pointed out, in a rack environment, there's another instance somewhere. In a data guard environment, it's a physically different database. But by using the recommended connect strings, we can find where your data is now available. And application continuity connects you to the database and then validates everything that you've seen in the context of that request. And if all that data matches, then it'll reissue your transactions or it'll be in the process of reissuing your transactions anyway, but it'll reissue your transaction and then hand control back to you. So you never get to your catch block and you just continue on processing as if nothing happened. There might be a small delay, and that's typically what we'll see because we do have to reestablish the connections, and that might take a second. It might not. But you just go back to processing normally. Now, if you do get the error, then if you do get an error, then you'll be able to handle that within your application logic, right? And figure out what to do. If you've lost your seat, then you might have to choose a different seat on the airline. But it's done underneath the application. You're not having to code it. And so by the time it gets back into your catch block, we've already tried the resubmission approach, and you then have to handle the outcome after that. But if you don't get there, you just continue on.
Yeah. And I think there's two aspects of the key to what Troy was saying here. One is, do you notice the slightest delay in response? A second is probably on the extreme high end for response for the delay as part of the replay, depending on what you're replaying, of course. If you're running a query that runs for 3 minutes and we have to replay it, well, it's going to be 3 more minutes, right? So, you got to take reasonable amount of logic to it, you might say.
Yeah.
But for OLTP, those are seconds, at most. So sub-second replay and so forth and response is not going to be noticed, whether it's, 10 milliseconds or 20 milliseconds. Who cares?
And that's the thing. And we have many examples of OLTP systems where the delay is,
immeasurable.
It looks significantly big, as Ian says. It doubles. It goes from 10 milliseconds to 20 milliseconds. But that's just that one submission. Then it goes back to being 10 again, or 2 or 1 millisecond, and whatever it happens.
And I challenge you to be able to, with your eye, to figure out the difference. Yeah. Obviously, if you're doing a switch over or failover to data guard, then it's a bit bigger, and the processing accordingly. But that's all managed for you again. So that would be one of those things that, how do you handle that in your application? And that's less likely to happen, we know, but we still provide coverage for it, and you can tune and deal with that separately.
We have just one more point on that. We have some extremely high-end OLTP customers using this who have transaction timeouts at 500 milliseconds. So to fall back to your application logic at that point, you're probably already going to exceed that, and then you're falling into a bigger issue than having the replay or not.
And that's an interesting point. I mean, can you will your users or your logic in your application appreciate or be able to respond quickly enough? So
it's an interesting concept that, if I've understood correctly, we as developers, most of us treat the database as a black box. We have a connection pool. If the connection doesn't work out, we return it to the pool, get another one, and essentially hope for the pool to do the right thing. Now, it's fair to say, as far as I understand, most database technologies out there actually do not offer the high availability capabilities that Oracle brings to the table. So, things like real application clusters, being able to cluster a database, and data guard that has been mentioned before for disaster recovery, having to essentially stand by a database on another site and transparently failing over to that. So, when we code our application, I think we developers, we think a lot about, okay, I get a connection, I do something with the connection. If it fails, a network glitch, the database gets unavailable, well, there's either two outcomes, right? So either I had a network glitch, I abort, I basically catch that error, ask the connection pool for a new valid connection, which it will either give me because the network glitch has been resolved, or it will fail altogether because in other database technologies, I had only one single instance, the instance is down, the server failed, or something else, and basically have a big outage. But with Oracle, I don't have that necessarily because we have real application clusters. If an instance fails, if a server fails, another server will take over. Even if an entire site fails, data guard will take over, the other site will become the primary. So it sounds like an interesting, added topographical complexity as to what your database infrastructure looks like for the developer that the developer can perhaps not predict, right? So it's like, if I were to code this all myself, I do not necessarily know as a developer whether I have one instance there or there might be a cluster of 10 instances there and which one to connect next. Or on top of that, perhaps even have data guard on top of your application cluster and what's my standby site that I have to reconnect. And it sounds like application continuity essentially allows me not having to worry about any of this. If I understood fully correctly, what will happen is if a failure occurs, application continuity will take care of that. It will figure out what it has to reconnect, where it has to reconnect. And my application will essentially see nothing else other than the request that perhaps just failed while I was in my JDBC execute statement, for example, will just take slightly longer. But in the meantime, I could have had a complete disaster recovery failover. I could have reconnect to another node, or perhaps even to the same node if there was a glitch. So basically, I don't have to worry about any of this.
Yes, and that's essential. I mean, we've always done this for rack systems and data guard, in that we want to hide the physical systems underneath the covers. It doesn't matter to a user or an application developers to which node in a rack cluster they connect, as long as they can get to their data. And so we anonymize all that and we hide it behind the scenes. You have a single connection string. And the other benefit to this is also we've seen cases where, for maintenance purposes, where you're having two DNS connection string. Customers have deployed multiple connection strings, one for the primary site and one for the standby. And if they do a switch over or a failover, then typically they have to reboot all their application servers to re-authenticate against the DNS. That makes no sense whatsoever. I mean, it's a huge impact. We're not talking 2 or 3 minutes. We're talking 20 minutes, 2 hours maybe. I mean, and no user is going to be happy with that. So with application continuity and the connect string variations we've suggested or recommend, I should say require, this is all hidden and it's all taken care of for you. You don't have to do anything. You just have to sit there and have a cup of coffee, because your applications and the workload behind the scenes is being processed for you, regardless of where. And you shouldn't have to worry about that. That obfuscation, you might say, of or hidden hiding of the physical nature of the database and your connecting details, doesn't matter.
And just to extend that a bit before you ask to say something else, Gerald. As Ian said, it's the connect string that governs all of that. Application continuity in itself isn't involved with that. It just takes advantage of the fact that we're using services and we're using things like scan listeners in the rack case, or global data services in the disparate data center case, geographically displaced data centers. So application continuity is part of a collection of features and products that hide the complexity. As Ian said, it hides the physical infrastructure from you. So you build your application to use a connection pool, and or not. I mean, we don't have to have that, but we recommend it. And then your connection is to a database service. And where that service is not the application's care. It could be on a different instance. It could be in a different data center. On any given day, it could be in a physically different database, right? The application just needs to access its data, and its data is at that service. So wherever that service is running, we will position you there and connect you there. And if the service moves, which is the concept that we're talking about, either for maintenance, you're being moved off a instance or a node that's about to have some changes made to it, or as a reaction to a failure where there's been some physical failure, we'll move that service automatically for you. And your application just says, I need to connect to that service, and it goes to wherever it now is. And so provided that you think about that and you don't tie yourself to an instance or to some physical hardware by coding those into your host name in the connection string or the SID in the connection string. You just say, I want a service. And here's my obfuscated host, which is the scan listeners, which came out in 11.2, which hides all of that physical complexity from the application. And then we can manage its availability underneath.
Yeah.
It's quite interesting and sounds fascinating, right? In the day and age of cloud computing, developers have to think much more about all the infrastructure that they just have on the click of a button, but not necessarily control. So even though while in-house, perhaps somebody would know what a cluster layout looks like, or even a DR layout looks like, in cloud, that's all very opaque. And developers have increasingly more complexity to actually add code to make sure that the orchestration across the different services in a cloud environment actually happens and fails gracefully or replays gracefully. And it sounds like, with Oracle application continuity and Oracle database, that big chunk of what do you do, how do you prevent from adding a record twice, billing a customer twice, or, not billing a customer while the server in the cloud perhaps is, my service is going to another server, my database is moving somewhere else. I don't have to worry about any of this. Basically, it's all taken care for me. And I can just focus on my application code, write the business logic, and off we go.
Yeah, and that's all it is. And that's the aim that we have. Our real objective here is to make it so easy to use that you don't even think about it. Obviously, we want you to test it, make sure it's working, confirm that. But after that, it's just press the button and away you go. And that is, our target here. Many customers are already doing this, and there's no reason why others could not also just take those 4 steps to get there as well.
This sounds fantastic, but the 4 steps, if you don't mind my skepticism, sounds a little bit too good to be true. Do you have an example or a demo that you could show us where you actually show us application continuity in action?
Funny you should say that. Just give us a moment and we'll key up the demo.
Oddly enough, we happen to be able to demonstrate this to you right now. So application continuity was introduced with Oracle Database 12c. And in this example, we're just going to look at a very simple application. We happen to be using Java, and we'll demonstrate how application continuity can protect you against outages, whether that be from planned maintenance or failures. We'll hide the interruption as well as replaying any uncommitted transactions. And we're doing this underneath the application without having to make code changes. So this is a collaboration between the application and the database in order to achieve this. So here's my simple Java application. It has a couple of classes. It's configured with a property file so that we can change parameters easily without recompiling. And in this application, we are using the universal connection pool, and we've configured fast connection failover as well as connection tests. So we're validating connections on borrow. We have a number of worker threads that are accessing the pool, and within those workers we perform our database operations. So this is the worker.java file, and you can see that we are running some selects in a loop just to generate round trips to the database, and then we're doing some DML. We're performing an insert into a table. The application does have its own error handling code. So if we get a SQL error, then in our catch block, we're going to validate the connection to see if it's still available, if a connection is still available. And then we will attempt to reconnect to the database. And if we get too many failures, the application will crash. As I said, it's a very simple application. So we know that we're using a property file to configure the application. So here I have two property files, and I'm going to run them simultaneously. The property files are identical apart from one key thing. The one on the left is using the replay data source, and the one on the right is just using the regular pool data source. They are both connected through the same service, which has transparent application continuity enabled against it. All of the pool properties are the same apart from that. So we're now starting the application. The view on the top is using the replay driver. It's using that property file with the replay data source. The one on the bottom is using the regular pool data source. We recommend the use of connection pools because the cost of establishing connections is expensive. And you can see with this example that it is taking a while to build the pool and establish all the connections to the database. Once the application is running, borrowing a connection from the pool is a much quicker operation. You can see now that the application is getting connections within a few milliseconds. But what happens if there's a failure? So here we're just using SQL Developer to connect to the database, and we're killing the sessions. You can see the application on the bottom using the regular data source is getting a whole lot of errors associated with the failure of those connections. TAC is protecting the application at the top by re-establishing the connections and replaying uncommitted transactions. The application does have error handling, and it is able to re-establish those connections, but then it's the application's responsibility to determine whether the transactions it had submitted had committed or not. Now this is a simple case, but we can work with more complex cases. And here's an example using Swingbench and the order entry application. We've induced a failure there due to a database crash, and you can see that application continuity is protecting all of the uncommitted transactions in the case where it's enabled.
Okay, so here are some further resources available for you. The application continuity product page, easy to find. Go to www.oracle.com, go to AC. There's a lot of reference material there, including all of the technical briefs and presentations from recent open worlds from customers, those ones who have deployed and benefited greatly from application continuity and draining and so forth. Some good examples there from the Chicago Mercantile Exchange with very high performance demands, through other smaller organizations such as Epsilon and Rain and Hail Crop Insurance, both benefiting greatly from the improvements they see for continuous availability for their applications and for just workload draining, preventative or planned maintenance activities. Two key technical briefs I want to point you towards, though. These are the best references to start with. There's a deployment checklist, okay, and that's there on the front page of the application continuity product page. You'll see it there, middle box, right beside me in my video. It is meant for developers, DBAs, and app owners about these are the instructions, all the details required to actually do this in more detail. So if we want to talk about Java coding and so forth, and what is meant for best practices and what's a well-behaved application, it's in there. What you have to define for these database services that Troy was discussing, it's in there as well. Okay, all the details. The best place to start, it positions it well. You should also be, and it also includes that connect string we've stressed quite a bit. Okay. And part of that connect string is enabling fan. And if you use that connect string, fan is automatically enabled or automatically configured for you, which makes it far, far simpler than it ever was in the past. So fast application notification is key, absolutely key, as are services for all of this. They go hand in hand. And it's that fast application notification that tells your application that there's something wrong, do something about it, and it will automatically reconnect, and then replay will take place, and so on and so forth. Okay, this is a fast connection failover, as it's known in Java. But it also applies for OCI and other applications structures as well. So your application needs to be able to respond to receiving fan events. Fan events in this case would be stipulating that your database service that you connected to is no longer available. It may be because there's a planned down event. You've taken that service down so you can do maintenance on that node or instance. But it may be an unplanned, an outage, whereby the node has disappeared or the database instance has failed, or your network connection has failed. The public network is down. You'll receive this message and consequently do something based on that. And this should be all, this is just a configuration change. It is not a requirement for you to code anything into your application. That capability should already be built in, especially if you're using connection pool, and then it reconnects and then replay takes place and so forth. Same goes for load balancing events and then startup too. As you add a new node to a rack cluster, so to speak. You're on 3 nodes now, you add a 4th node to spread the load even further. You're increasing load and so on. Well, now you want to spread the load automatically. Your application shouldn't need to know about this. Connection pool will do so based on the fan event, so on. Okay, so these are some other sources for you. Thank you very much for attending, and the recording will be made available fairly soon.